Okay, so when dealing with the conic with questions like this, we have a conic section, and then they've given us the eccentricity. They've also pointed out where the center is, and then we have the directrix at that point. How do we approach a question like this one? Well, for this, before you even start working it out, there's one thing that you need to understand. Once you understand it, it becomes easy for you to actually work this one out. First, let's sketch a parabola, and let's put down a few key items on a parabola. Not a parabola, sorry. Yeah, this is going to be a hyperbola. And you not say it's a hyperbola by looking at the eccentricity. And you not say when the eccentricity is greater than 1, then you're dealing with a hyperbola. So in this case, 3/2 is greater than 1. So this is definitely a hyperbola. So let's sketch down a hyperbola so that we understand what holds a hyperbola together. Okay, so what do we need? So for a hyperbola, we know to say for the main one, the one we used to derive our equations, I think it had a piece that opened to the left. It had its line of symmetry, the horizontal line. And then, of course, we have two pieces. One piece opens to the left, while the other one opens to the right. And then, of course, it's symmetrical. So here, the line of symmetry or the main diagonal of the main axis is the x-axis. And it's symmetrical about the x and also about the y. Okay, so something like this. Now, in an event that you have the directrix of a hyperbola specified, and in this case, we do see that the directrix is being specified right there. So in an event that you have the directrix specified, you can just view the hyperbola as if it is two parabolas that have been drawn side by side. So that this will have a directrix that is here, while this will have a directrix that will be here. Now, don't confuse this for an actual parabola, which is governed by the definition of a parabola. This is not a parabola. This is a hyperbola. Now, let's say these two lines, they give us the directrix, this giving us the directrix of this piece, and this, not that, this directrix giving us the directrix for this piece. Then what you have to understand here is, for this being the focus of this piece, given by negative c, meaning the distance from here up to there being c, perhaps I should use something else for that. Okay, I can go with this. The distance from the center, I'm specifying the center, up to where the focus is, being c, so to the left being minus c, and to the right being positive c. And since this is the origin, 0, 0, this has to be positive c there. And then next up, the vertices. This one here is going to be, we know to say this has to be at minus a, the distance from the center to the vertices, that is a, and also from the center up to here, this is going to be positive there. Once you have this in place, what you have to understand here is that the directrix for a hyperbola, in this case, will have a specific expression that we can use to get it. So this one here that is to the positive side, will have an equation x equal to, and this is going to be a over e. While this one going to the left side, since the distance from here to this one is the same as the distance from here to this one, it implies that the other one will have the same expression, but it will just be negative. So this is going to be minus there. So this is what we're going to have here. So this is the equation for this directrix. This is the equation for the other directrix. So with that, once you understand this, notice that there are a few key concepts that you can conclude or that you can then identify here. Firstly, depending on what you are given, you now know the distance from the center to either of the directrix lines. This distance is A over E. Secondly, since if you know where the focus is, you can end up concluding that the distance from the focus up to the center, of course, that distance is C, but the one I want to actually go for is the distance from the center up to the directrix. This distance can be written in terms of A and C. What do I mean? You see, let me use the positive one. The distance from, not the center, from this directrix up to the focus here. You know, to say to get this distance, since C is the bigger one, and where the directrix is, that's the smaller one. From here to the far end, that is C. From here up to here, that is this value, A over E. It implies that this separational distance between the directrix and C can be obtained by saying C minus A over E. This will give you the distance from, or let me not say from, the distance between the focus and the directrix. So this is what this distance is going to give us. So I think we're going to find another question that where this is going to be useful. But with this simple description, let's answer a few questions to just get in shape. Look at this one. We have a conic section that has eccentricity E equals to 3 over 2. And here, so given E is 3 over 2. Next, we're told that the center is at 3, 2. And one equation of the directrix is X is equal to 5 over 3. Identify the conic section. That's the first thing they want us to do. So if we now try to answer this, how do we approach it? So the first thing they want is the identity of the conic section. Well, to get the identity, we use the fact that if the eccentricity is equals to 1, we're dealing with the parabola. If the eccentricity is less than, so let me use an interval. If 0 is less than the eccentricity, which is less than 1 as well, then you're dealing with an ellipse. But if you have E is greater than 1, then you're dealing with a hyperbola. So this is what you should keep in mind. So this is what you need to know when working out this one. Now from here, now what we have is E is equals to 3 over 2. So 3 over 2 is definitely greater than 1. So again, this is a hyperbola. Let's go to the second part. In the second part, they now want us to write down the equation of the conic section. So to write down the equation, I like going with a sketch first so that you can create a mental picture of what is happening. So you have this. You have this. So first, the question gives us what? They have given us the center where it is. The center is at 3, 2. So go with that center first. And that is at 3, 2. So place a 3 here, 2. So place our 2 somewhere here. So this is where the center is. Next up, what else? So they have given us the equation of the directrix. So they're saying that the equation of the directrix, where is that? Somewhere here. It's X is equals to 5 over 3. So 5 over 3, what does that represent? So 5 over 3, 3 goes, that's going to be 1 point something. So if this is 1 somewhere here, and this is 2, then 5 over 3 has to be somewhere between 1 and 2. So we can conclude that the directrix is going to be somewhere here, which is at 5 over 3. Now, if this is our directrix and our center is at this point, so we can conclude that, well, the other directrix is probably going to be this side. Then our two shapes are going to face one this side and the other one this side. Don't really know exactly where they are, but here we're just trying to predict how they open. And now we know how they open. They are opening sideways to the left and to the right. But to actually get the equation for a hyperbola that opens sideways, we know to say the positive one is the x term. So we have x minus h squared over a squared minus y minus k squared over b squared is equals to 1. From the fact that the center has been given, and the center has been given as 3, 2, we now conclude that this is our h and this is our k. So the center has been translated. So this is x minus 3, and then this is over a squared minus y minus 2 squared over b squared is equals to 1. Next up, from our eccentricity, we have E is equals to 3 over 2. But we still recall that eccentricity by definition is equals to C over A. This implies that this has to be the same as that. So that we have 3 over 2 is equals to C over A. And finally, 3A is equals to 2C. Once you reach this part, we can't go any further than this, so we're going to hold on to this as 1. Then the next thing we're going to look at is what we were describing earlier on. Earlier, we did notice that if we know where the center is, and we know where the directrix is, this distance here can actually be described. The distance from the center to either of the directrix can be written in form of A over E. Based on that, we can conclude that, okay, if we can have, what's that? A over E. Where is that again? Okay, so we are given the center. The center here, this is the x value is a 3. The directrix, so it's like you have one line, the directrix that is 5 over 3, and then you have the center. The center lies along this part where the x value is a 3. So the distance between these two, we know to say it's given by A over E, but you can still subtract these two to get the same answer. So if you subtract 3 minus 5 over 3, this should also give you the distance from the center to the directrix. So I hope you've got that part. From this diagram, we know to say the distance between the center and the directrix is A over E. But knowing that the center is at 3, yes, the center is at 3, 2, at 3, and the directrix is at 5 over, that was 5 over 3. Then we can subtract 3 minus 5 over 3, and it should be equal to that A over E difference. So this is what I'm using there. So that's E, yes, 5 over 3, that's okay. So with that figured out, we can now just simplify that expression. We now have A over E is equals to, as a single fraction, that is 9 minus 5 over 3. Multiply everything by 3. We now have 3A over E is equals to, this is going to be 4 this side. But we do know what E is. I can even multiply here first. 3A is equals to 4E. But E is equals to 3 over 2. Because E is 3 over 2, this becomes 3A is equals to 4, 3 over 2, since that is our eccentricity. So the 2 goes twice here. We now have 3a is equals to 6. And here we end up with a is equals to 2. So I hope we haven't made any errors, any error. If we haven't, this is exactly what we get. If we have, just follow the same steps, you'd still get the answer. So now we have our a. And with our a, it is, okay, I hope, yeah, we found our a. With our a figured out, we can now get a, bring it in this expression, bring a in this expression, and this becomes 3, a is 2, 2c, 2 cancels with this, c is equals to 3. So once we have a and we have c, we can find b. For a hyperbola, b squared is equals to c squared minus a squared. So b squared will be equals to c squared is 3 squared, a squared is 2 squared. This becomes 9 minus 4. So this will be equals to 5. So b squared is equals to 5. Once we figured out those, we can now go back to our expression. Only a squared and b squared were missing. So now we can substitute what those two are. So we have this, where we have a squared, a is 2, so 2 squared is 4. And where we have b, b is, we have b squared, so b squared is 5. So where we have b squared, we'll put 5. So this becomes the equation of that hyperbola. The last few parts, find the center. We did find the center already. The focus, knowing that we already have c, c gives us the distance from the center. The center is 3. So if we just do 3, if we add c, our c, we found 3. Did we find 3? Yes, our c was 3 here. So to the center, which is at 3 here, if you add 3, it takes you to 6. So the focus, this one here, is at 6. What else? So it's that this one here is at 6. When you subtract 3, the other, so this is the focus, sorry, not the center. The focus is going to be at 6. This one here will be at 6. Well, the other one, when you subtract 3, going backwards, because I'm saying subtract because they're going back, is going to end up being at 0. So this focus here, if I was to write both of them, the foci, one is going to be at 0, 2, while the other one is going to be at 6, 2. The vertices, you know, to say you're dealing with 2, a is 2. So from 3, add 2. It will tell you where this vertex is going to be. So 3 plus 2, this is going to be 5. And then 3 minus 2, it will give you 1. So this vertex this side is going to be at 1. So you can write it like this. So this one is at 1. And here we also have this one with the vertex at 5. So basically, this is what you're going to have. The vertices, you have 1, 2, and the other one, 5, 2. So I think with that, we have answered everything. We found these, the direct. Well, the only thing we haven't found is their asymptotes. But for this one, they didn't specify the asymptotes. So basically, we are done. So this is how you'd work out a question like this one.